Good evening, everyone, and welcome to day three of GitHub Developer Tech Camp. So, today we are over here to understand what DevOps is. Over the last 2 days, we have been learning how we were actually working with GitHub. We got introduced to how to generate a PR. We had raised certain issues yesterdays. And today, what we'll be doing is that we'll be going a step ahead, would be working around with certain circumstances wherein we get to understand how actually industry today is utilizing GitHub for deployment and development purposes, whether it is coordinating with the team, whether it is working along with a team, or whether it is we go through the entire enterprise version of how people are actually using it in the industry. So today we will be having Mr. Prasanna Raghavendra from Jfrog. Prasanna Raghavendra is the director of and R&D of Jfrog India. So just to give a brief about him, Prasanna has been driving product development for Jfrog product for past 3 years. Before joining JFrog, he was the CTO and co-founder of CloudMunch. So he has got a huge lot of experience under his belt with DevOps and DevOps related platforms. So he is with us today and he will be helping us getting understand how actually DevOps is changing the way we are deploying our projects in the industry. So before he joins in, we'll be just going through certain highlights of what the GDTC has been throughout these 2 days. So we have covered up a lot of aspects. We have been throughout lot many organizations or colleges across India who have actually been part of GitHub Campus program and have been connected to us through Code Innovation Series. So we have brought together these organizations. So I'll just wait for a couple of seconds, and if Prasanna is there, we'll be just joining him over. So he'll be joining us and letting us go through the entire workshop and getting understand how actually GitHub is helping the entire deployment scenario and how important DevOps is and DevOps tools are.
Hey guys, can you hear me?
Yes, Prasanna, we do hear you.
Awesome. So let me try sharing my screen. Just
Yes, sir.
confirm it works. Can you see my screen?
Not yet, Prasanna. We don't see your screen.
Right. Hold on, I think I need to enable my.
So while Prasanna is joining some certain technical issues, what we'll be doing is that we'll just get a brief of what for those who have joined in right now. We were just going on through the what actually GitHub is, and we got to understand these over the last 2 days. So basically, how GitHub is actually, when we are talking about GitHub, the first and foremost thing that comes to our mind is that how is actually it impacting the industry? Because at one end, we do know that okay, yeah, it has changed the way in which enterprise is working, but how actually it does help the industry, because we do see so yeah, before we just jump in, we have got Prasanna back live, so I'll just add him.
Can you see my screen this
Yes,
time?
Prasanna, we do see your screen.
Awesome. Okay,
Yeah,
let me know when I can start. All
yeah,
here.
it's over to you. Thanks a
Okay,
lot for joining in. So yeah, over to you, Prasanna.
awesome. Thank you so much, Kaushik and Incubate IND for this opportunity. um, so first of all, just wanted to talk about what we do at Jfrog. Briefly. We are into DevOps, and that's why this topic is very, very close to us, and hence, taking up speaking about DevOps in this event as well. So what I put together as an agenda is I wanted to, like Kaushik said, while you start, building software. We start with code, but later we realize when in the industry, making sure the code works is the hardest problem. Making it work for the first time is great, but making sure every time you change it continues to work is a little harder problem, and that's where DevOps comes in, and we will talk about it. What exactly it means. So that's the first point in the agenda, and then we will talk about a high-level playbook, how the industry looks at DevOps. And I wanted to show you guys a simple implementation as to how it works, in one of the open source libraries that we support. And then I wanted to talk a little bit about the runtime, which has gone through a significant amount of changes, and that is very, very important, in making sure the DevOps, cycle works the way it should. And then there is a concept called 12-factor app, which I think is something that you should start learning day one, so that you can continually build something that is always usable and deployable. And finally, I just briefly want to touch about a growth dream, which I myself have experienced. When you actually build a company and you want to grow it continually, what are the ramification you need to do, and how DevOps can help there. All right. So that said, let's start with a strip. The burning question in most of our mind, especially when you're learning software, is it an art or a science, right? And this comic strip explains it very well, where I'll let you read this, but the summary is it's very hard to define what you want, right? So while software can do anything you want, but you really don't know what you want. I think that's a dilemma that the whole industry has been going through. So in this context, assuming you've read, I'll move on. The question really is it a science? It is science, because software is very descriptive. You can clearly define how to write your code. There is clear syntax, what to follow, what not to follow. There is a compilation process. There is a data model. So pretty much it is well defined as to help you build what you want to build. On the other hand, it is also a fiction, because end of the day, the user does not exactly know how to realize or reap value out of what gets created until it is created, exactly like the comic strip was saying. And in this whole dilemma is where the whole process of engineering comes. It's not just in software, in various other industries. When you have a very good science which proves something can be done, the value is fictitious, engineering comes to the rescue. It helps you really realize that value, and therefore you should look at software as an engineering, right? So I mean, you've really heard the term engineering, but for the last few decades, 40, 50, last 4, 5 decades, what we have seen is we have tried to bring this engineering to the fore. There have been many attempts to do it right. There have been various kinds of solutions that have been brought out. But I should say, in the last decade is when it is really falling in place, right? And I wouldn't say DevOps is the only reason. There are multiple things that have come together, and we are now touching and feeling software engineering as it should be. Now, why do I say that? So if you look at Google Trends, the red one is a search for agile, and blue one is search for DevOps, right? Agile has been there, Agile has been there for quite some time, but at the same time, it has not really given the complete value from an implementation perspective. It has given significant value of the approach, the process, but from an implementation perspective, there was always a dearth or a gap that had to be filled. And it was only in as you can see in 2010 or so when the actual engineering implementation started following it, and it has as you can see, it has really taken the mind share, and it is growing, and it is reaching leaps and bounds alongside of agile. And now agile and DevOps kind of go hand in hand, and it makes a lot of sense. And again, it has been universal, it is global. Every other country is looking at this as a solution because it's pretty much a global problem. And the reason this becomes really, really important is because software has eaten the world. There is no industry where software is not being used. And because of this, you need to really now make sure you can deliver what you promise. You cannot lose that, right? In that context, having an engineering solution, having a solution which you can touch, feel, and repeat again and again has become a universal problem, right? So and therefore, there is, let me skip a slide here. Therefore, you have a DevOps ecosystem that has grown, significantly. Take any area, there are tons and tons of vendors, and including ourselves, Jfrog, have been contributing to this space, and for the right reason of making sure software is successful, it delivers value, and repeatedly gives that value to the consumer, right? So in that context, what exactly DevOps bring to the table, right? So the analogy of the art when I started is very important to understand, because when you deliver software, it's almost like telling a painter to do a portrait, right? So when I'm a model and I'm sitting in front of a painter, you can only say, please draw my portrait, right? So when the artist comes and starts drawing it and finally shows what he did, it definitely doesn't look like what I look like in the mirror, right? So there are gaps, and that is okay because it is art, but it is not okay when it is a business application, because I as a consumer exactly want what I define, but I can't define it, right? I think this is the global problem that continually software industry is trying to solve. We've done leaps and bounds on that, and we continue to do that, right? So in that context, what does DevOps bring? First of all, it makes the releases, call it these incremental pieces to be done more frequently. What does it mean? In the example of a painter, you can ask him to show after an eye is done, just to make sure, or overall boundaries are done, so that you can keep on giving him feedback. Hey, don't do it black and white, do it colorful, don't use this color. So you can continually give that feedback. And for you to give that feedback, he should have all the tools and technology for you to for him to show piecemeal. He can show only this and then ask you, if that looks good, right? And that ability is not a simple ability, right? And that need to be done, for software, especially for large systems, and that DevOps brings, on top of the agile process. DevOps makes it easier, and that's point number one, right? So that you can learn and iterate quickly, and therefore start moving towards the target fictitious solution that you're looking at, right? The second one is, while you do this, you need to really do a dipstick and understand if the customer is liking what you are adding as a feature, right? So the market obviously keeps changing. Their expectations are different, and you as a software developer may not know everything about what the expectations are. So you need an ability for you to respond to those market conditions and requirements, right? So that is another big ask from a software development perspective. And the third one is, while you do these two, what has happened is, this is taken as a challenge, and folks have built infrastructure to do those two. Hey, I will do dipsticking. Let me bring a big server, only to add new features and give it to a few customers of mine, and then seek feedback, and then release the whole solution. And when you start doing it, what happens is, you will start spending more on the way to deliver rather than focusing on innovation, right? So the whole DevOps problem was, hey, I don't want to do this. The infrastructure should be a given, and I should, as a software developer, should focus on innovation, right? And the last but not the least is, while doing all of this, you want to make sure each role in the ecosystem are are happy. They can continually do, because this whole cycle need to happen again and again and again, right? So in that context, you need to make sure a developer, I always want the developers to be fearless. They should not really worry about, oh, this is a mega system. How will my little change in code break it? I don't know. Therefore, I might rather not change it, and silently manage it, with a log, right? So that making developer fearless is important. IT operations typically was not at all involved in the whole cycle of creation. They were asked, okay, give me a server and I will take the rest. So this was causing silos being built. Now, by having a DevOps integrated process, they come in and they are more involved, right? Runtime, what I mean is the production system, keeping production system up is part of the DevOps cycle. It doesn't leave at delivery. It leaves at deployment, it leaves at monitoring, and it leaves at automated running of these systems. And all these three will lead to the business line owners to be more confident, because they can dipstick as and when they want. They can control what's going on with the consumers, and when to release, when to maximize each of these features going to all their consumers. And finally, the product manager who gets this feedback can be more informed. He can now say, hey, this feature is more valuable than this, and therefore let's prioritize that first, right? So in this whole ecosystem, the beauty of DevOps is it tries to bring all these roles together and tries to make them more effective in whatever they do, right? I'll keep going, and if you have any questions, please feel free to throw them in, and I can take them later. So I spoke about this. I didn't want to. So what exactly DevOps then would bring to the table, right? I think you've seen all of this in different manifestations, in different talks. But the beauty, while I'll mention all of them, the beauty is that vertical line. The key you should focus on is continuous value delivery. Is the change that I am pushing today is making sense to the end consumer? If that cycle is not effective, then it is not moving ahead, right? So you start with source code, which, like Kaushik said, GitHub does a wonderful job of that. Then you integrate into your test framework and make sure you can test whatever you're changing. Then you create binaries out of it and store the binary, and I'll come to it exactly what it means, and then use those binaries to continually test those binaries across all the dependencies that you need to be bundling. And finally, make sure each of these binaries you are bundling, you're dependent on, and what you created are secure. There are no vulnerable binaries that you're trying to bundle or using. And then take all of this nicely secured binary and put them into your production called continuous deployment. And then finally, once it is deployed, you need to have an automated way of expanding and contracting and putting features in the right places, allocating only part of the features to be used by consumers, and finally monitoring this whole thing so that you can do this all over again by changing code. Right, and that pretty much is a simple DevOps playbook. While it looks complex, the beauty is, like I said, in the last 10 years or so, there have been plenty of innovations that have come, which have made this whole cycle quite easy to implement, I must say. All right. So having said that, let's start now. What exactly, let's take some specific parts of what it means. When I start as a developer, I am looking at writing a piece of code. Let's say I have nothing, and I'm now thinking of building, let's say, a login page, right? Today, there is a recent, not recent, I think in 2018, Dan from CNCF was talking about how much of code you write runs in production and what percentage of this. It's very interesting to see that only 1% of the code you write runs in the production stack. 99% of the code is already sitting in production. All you're doing is this 1% of the code, right? So in that context, when you are starting from scratch, it's not really scratch. You already are dependent of bunch of dependent binaries, right? So before you start thinking of writing something, you're already thinking of what am I dependent on, right? So that is where your declaration of new dependencies come, right? You need to now say, okay, I am going to write Java piece of code. Here are my includes that I'm going to add, and here are where I'm dependent on. Once I say include, then you need to now make sure those includes are available for, in your class path, and therefore you got a POM XML, and now you need to define what those are. And once you got the POM, now you need to define that in settings and say, okay, hey, here is where I'm going to pull these dependencies from. And that's where your artifact manager comes, right? So when you start, you already are dependent on a bunch of binaries. And those binaries, now you need to be pulled from somewhere. You can't say, I'm going to download myself and put it in my laptop. The main reason is it is not just one developer, it's a team. And later it becomes, systems. And later the same thing has to go into production. So you need to make sure all of these binaries that you're dependent on are not directly downloaded into your laptop, but it is put somewhere. And that's where artifact manager comes. So you need to take these binaries that you're dependent on, declare those dependencies in a POM or a NuGet, various kinds of dependency manager, and then make sure those configurations connect to an artifact manager. And one of those artifact manager is Jfrog Artifactory. There are plenty of them. I just want to make sure where this comes from. Now, what this does is once you define, you can also define your remotes, in the sense you can tell, hey, if you as a binary repository don't have this dependency, pull it from these places. It could be a Maven Central or a JCenter. It could be various mirrors and sites that are available which host all these dependencies to be pulled from there. The main reason you would want to do it, because you don't want every developer pulling from these sites to make your bandwidth reach the limits of usage, right? So it will pull once, and now it is available in your network for all the developers in the team to pull these dependencies. Right? Now that you have sorted out these dependencies, now you have made your changes, you now can compile, you have this application looking good in your local environment. Now you're happy and you want to commit the changes. And that's where GitHub comes in, and that will ensure that your commits are completely controlled. It is visible, their history is visible, and everyone else knows who made what changes, so that there is complete clarity and transparency of the code changes that are happening in this application. Right? Once you have this, you will then typically want to test this change, because a new change came into your code base, but there was hopefully some other code that was existing. Now with this new change and the existing code, you want to test it. Right? And there are a bunch of CI tools that are available, Jenkins to be prominent. Jfrog has another tool called Jfrog Pipelines, which basically takes the changes that have come. It will take the change, like Kaushik said, it could be a PR change. So before you merge into the master, you can take the PR, find the master, which is the golden source of truth, merge them, put it in an environment, test all your functionality, and then say you're good. Right? And that's the expectation of a continuous integration tool. But while you're doing, you need to now build it, and therefore you have a dependency again. Right? So it could be any language, it could be Maven, NuGet, Ruby, etc. So you will go to the build system where it will start building. Right? When it builds, again, it finds those dependencies. And luckily, this time, since the developer has already connected to Artifactory, that dependency is already sitting in Artifactory, and it will resolve those dependencies. And now you have been consistently using the same versions of the binary. Therefore, it will work. Hopefully, but it will work, right? So you will see that the compilation has happened and it has used the right version of the binary, and it will start testing. Once this is successful, typically what happens, it will create a new binary, which is now an integrated, tested binary, and it can potentially push or deploy that binary into Artifactory again. So now you have the dependent binary sitting, and also the binaries that you have created, which are dependent on this binary, into it. Right? So once this is done, it will also create something called a BOM, a software BOM, bill of materials. This one is very important because you will now need to know what are the content of this binary, without opening the binary. Not just that, you should also know what are the metadata linked to this binary. The reason this becomes important is you should start making decisions at a later stage when you want to take this binary. Hey, is this tested? Is this tested for high availability? Is this tested for this specific functionality that we are looking at this customer to use? Right? So you can have the sonars. Is it code coverage? I'm now going to send it to a defense organization where the expectation is the code coverage should be 99% plus. What was the code coverage of this binary when it was tested? Right? All of that can be pre-filled into the BOM, so that you know what is done to this binary. Right? Because you can't touch the binary, you have to add metadata next to the binary so that it is clear and it is packaged. And these BOMs are typically write only once. Once it is written, it is basically idempotent. You can't write it again. So this version, this is the BOM, this is the binary, and we are going to close that. So once you do this and repeat the cycle again and again, now you have a very good process for you to make sure you create something which is repeatable, testable, and taggable with respect to various metadata. Having done this, now I need to probably, if all the tests are comfortable, I want to deploy into production. you will use various kinds of tools and try to push into production servers by taking these binaries. There are various ways of what is called as promotions, where you start moving these binaries from a dev stage to a staging stage and production stage. So which are the approved binaries which are linked through the metadata, and then finally say, hey, here are my releasable, shippable binaries. And once those binaries are pushed there, it is now ready to be deployed into production. And depending on what is the nature of your company, you may have customers download, or you directly deploy into your cloud systems, right? So that's where if you are a cloud company, you will move that to a cloud binary repository, as it is called, where you basically once it moves into promoted to production, it will start automatically deploying into your production systems. And here is where Jfrog has something called Bintray, where you can roll out for on-prem distribution into Bintray, where you can start pushing hey, here is my production releasable, shippable binary, and I want to push that. This binary are again packaged. It could be an RPM package, a Debian package. So it's packaged. There are a bunch of installers come through, and you now push to something like Bintray, which basically provides availability. It's a mirror site where you can download from any corner and install on your local site. So it could be a person, it could be a device, or it could be a system that downloads and then installs. All right. So once this is done, while you do this, I want to showcase an implementation of this a little bit. But in this implementation, what I wanted to talk about is really two more additions. One is how do you push that to these cloud centers where you can download. In this case, I'm going to talk about Chart Center, which is deploying Helm charts for Kubernetes deployment. And then another thing is which is very interesting and important is when you start moving these binaries, it will also become supremely important that you start performing vulnerability assessment of these binaries, check them for any potential vulnerabilities against various databases, and make sure it is clean. And before you deploy into any downloadable systems. So let me just stop here and take you through an example. Feel free to throw in any questions. Kaushik, I don't know where the questions will come. Maybe I'm missing it, but I'll keep going. So here is Jfrog's Helm charts, which is basic. Helm chart is essentially another way to deploy your applications in Kubernetes. So now what we have done is we have.
Prasanna, shall I just drop in the questions right now, or wait for you to end this up and then put up the questions?
You can drop in the questions, Kaushik. No problem.
Okay. So once we finish this, I'll just once you close the screens here, then we will get to the questions. We have a few from the participants who are watching it right now.
Awesome. Okay, sure. So this is an open source chart or code base where which is managed by Jfrog. What we do is, Kaushik, you were mentioning pull requests. So when you make it open source, what happens is there are contributors will start contributing into your repo, right? So when that contribution starts coming in, what happens is you want to keep it tight, right? You want to make sure you give. I was mentioning about fearless developer, right? So you want to make sure it is easier for the contributor to make mistake. Even if he makes mistake, it should give him enough feedback saying, oh, this is what was wrong, so that I can correct it. Otherwise, it will start pushing and putting a lot more pressure on the system, right? So now one of my developers will have to sit and review this code and then give the feedback, and it will become a discussion by itself. So you want to automate that whole process, and that's where this whole piecemeal of like I was saying. So every contribution should be shippable, therefore it should be testable, and therefore it is deployable, right? So for example, here are the various PRs that are there. So I open this. This is a PR which clearly says what is going on, right? This guy has to agree to a license agreement. Then he lint script has passed. Lint of chart is passed. The install chart is going on, and it is still unclear whether it is successful. So it says some checks are not completed, 3 successful and 1 expected check. And once it finishes, it will scan every binary that is created and make sure all of them are green, and then says, hey, you're good to go. On top of it, there is a manual review in this case, and this is all provided by GitHub infrastructure. So when you build, guys, try to build in such a fashion that your code can be contributed. At the same time, you can have a filter as to what those contributions are, whether you're going to accept it or not. Now, what is happening here, is basically this is connected to an engine. It could be any engine. Here in this case, it is a pipeline system, which is Jfrog pipelines. Let me log in here. So this basically tests each of these PRs. Like for example, chart public PR, I see a failure. This is actually the one that is getting tested. So if I open, exactly what happens, it is essentially, just to show pictorially, it basically ran this successfully, it linted, it is successfully packaging chart, it is now performing the installation. And what it does once the installation tests are done, it basically scans each of those artifactory, and once it is satisfied, it gives you a clear answer whether this can be taken into the system as a change. And once that is successful, internally we push this to production, in the sense we say, hey, this is a clean chart, now we are happy for this to to be promoted and put into our production system, which brings to another instance we have, which is a OSS. As you can see, it's an open source installation that we have. So we have it will basically get filled here into Helm local, and this is now packaged as a remote, which is called Helm, which essentially mirrors whatever is coming into the system. And this one, to promote complete usage, to kind of provide a CDN view where downloads can happen across the globe, we have something called Chart Center, which basically connects to this, and now provides complete view of what's going on. It is now showing, hey, this one has these many issues from a security perspective, and various other things, so that the end user knows whether he should deploy or not deploy, right? So this kind of a complete automated piece, which is a very simplistic one, in what I'm showing, in actual production, for complex system, it will start getting into various other things, which I can actually add to as we speak. Kaushik, I'll pause here. Please ask any questions you may have, or the team may have.
Yeah, thank you, Prasanna. Thanks a lot for that wonderful learning experience of what actually DevOps is. So I do have a few queries. So if you could just stop your screen share, and then I'll just display it onto your. So there's a question which says that, sir, I'm a developer, but for me it is very hard to perform test and know the test cases. Is there any way how I can learn to test and how I can know different test cases for the same?
Awesome. So today, in the DevOps world, a developer means who writes code. He may write code to add feature, or he may write code to test a feature, right? So they go in hand. And as a developer, you should definitely consider what is called as unit test. So when you write a code, you write a snippet to test each line of those pieces that you've written, and there are various frameworks to support that. So as a developer, first you should learn how to write code, and parallel to that, how to unit test your code. That's the basic requirement of a developer. And post that, you should also understand how the developer sitting next to you, who is a tester, who writes the test code, and work with him so that you understand, or you can expose what you have written, and therefore what he can test, right? So that's a continuous process that need to happen. And only then, like I was saying, the need of adding incremental feature in a strong way can be done, right? So how can you definitely will have to learn a bunch of frameworks. There are various test frameworks. Selenium is one of them. Testim is another one. When you are looking at the UIPs, Gradle, Groovy, there are a lot of scripts which will actually help you focus on testing while you are writing your focused code. Does that make sense, Hitesh?
Yeah, I hope Hitesh must have got his answer.
Okay.
So I do have another question, which is from. So, sir, if I'm writing some code and that is already declared in the dependencies, will it affect my code execution time, or it will ignore my repetitive redundant code?
If I'm writing some code that is already declared, no, basically the dependencies are the libraries that your code is dependent on, right? So you will not be writing any repetitive code. So you write, let's say you want to use logging, right? There is already a code called log4j, which, when I'm talking Java in this case, which actually does logging very, very effectively. So you don't have to start writing, system.out. It does a lot more robust code. This is where I was saying, 99% of code is already written for you, right? You just have to, scrape through those 1% of the code base. And therefore, you should also look at what is already there, and not repeat, what is already existing. Focus on, your specific functionality you need to do, and never work on infrastructure. So when you start working on infrastructure, you should always ask, is this already done by someone somewhere? And then look for it.
So we have got another question from Tushar Anand. He has got a couple of more, so I'll just pipeline them. So first of all, he says, can we say continuous integration basically creates an environment where it tests whether the existing workloads are compatible with new upcoming changes?
Yeah, very well said. It does that. Yeah, I think you said it right, Tushar.
Okay, then he has some sort of another query which says, Helm charts is like a package manager of Kubernetes workload. I suppose you want to ask.
Yeah, and HelpChan is exactly that. Basically, what happened with Kubernetes config is there were a lot of YAMLs, people were throwing around. Helm chart came to package those YAMLs in a consistent, easy fashion, so that you can deploy, your workloads, in a better fashion.
So there's another query from Asgar. He is asking that how DevOps can help me to find vulnerabilities in my code.
So there are various pieces. One is, see, the vulnerabilities will not be okay. So there are two parts. One is the source code security, right? So when you build, there are a lot of guidelines that already exist, in OWASP, in various aspects, where your code has to be written in such a way that it won't leave any hole for hackers to use, right? So in that context, there are code scanning, security code scanning tools, which can, validate your code and give you guidance on what could be problem. There are also companies who review your code. When you really want to keep it very tight, they will review and give you guidance, saying, here are the potential aspects of vulnerabilities you have. And the third layer is the dependencies you have, right? Like when you, like I mentioned log4j, and if you take a version of log4j and make your binary, log4j may have a vulnerability. So you should find, not just your code, all your dependencies are also not vulnerable, so that finally when you pack in something, all of them are clean, right? So there are three stages of making your code secure.
Yeah, I've got another question from Tushar again. He's asking that is JFrog Chart Center similar to AWS CloudFront?
No, CloudFront is a generic solution, which is which is more a CDN layer for anything you want to put out there. Chart Center is specifically focused on Helm charts. It's not. It's more like a mirror for various kinds of chart, so that you can say, Helm repo. I think okay. I'm not sharing my screen. So when you say Helm repo add Chart Center, now you can start pulling, Helm install something, it knows, where to pull. Chart Center will go. It is similar to, your brew install on your local laptop, where it will find the dependency and pull whatever needs to be pulled, across various mirror shards. Right?
So I assume that this is the last question that we have. Ahmad is asking that is continuous integration and continuous deployment the main job of DevOps, and what else do they do?
Nice question. These are loaded terms. Let me take a step back. The idea of DevOps, like I said, how do I incrementally add feature, validate whether it is valuable, and then come back and fine tune that process. That is what DevOps intends to do. CI/CDs are helping there, but there is a lot more. I think when I talk about runtime, it is not just the deployment. I think the larger problem is how do you make sure the production manages itself as well, right? So we should look at that as well. But broadly, you need to look at the value that DevOps brings, from a software delivery perspective, than specifically focusing on CI or CD. But these are definitely the tools that helps DevOps.
So we have got one more question, which seems important to most of the students who are looking for jobs these days. So, what resources should I use to improve my skills in DevOps and get a job as?
Okay. So see, DevOps is a culture, right? So you first you should understand the culture of doing incremental updates, right? To do incremental updates, there are various kinds of skills you need, which you learn and unlearn. It's not that if you learn this, you will become a DevOps master, right? So, like someone asked, how do I code such that I can also test? Is a skill you need to have, right? It doesn't look like it's part of the DevOps culture, right? And then understanding how do I deploy into production is another skill, right? So the whole idea is, how do you keep your whole skill open to learn and unlearn is the most important thing, I should say. There are various tools. If you just Google DevOps, there are tons and thousands of tools which focus on CI and CD, but that is only part of it. Like I said, you should learn to code, at various levels, because infrastructure has become code, test has become code, development has become code. So you need to learn all of these kinds of code. That would mean you should have an aptitude to write and read code.
So I hope that with this we have got all the queries resolved for the participants. So thanks a lot, Prasanna. Thanks for joining in and helping us know what actually DevOps is and getting started with the beginners who are actually looking forward to land a job or actually working in a startup or are newbies. So thanks a lot, Prasanna, for helping us understand the architecture of DevOps.
Kaushik, I wanted to, do I have some more time?
Yeah, sure. We do have.
I'll just briefly conclude on the runtime, which I thought is very important. Let
Yes,
me
sir.
share, and can you see my screen again?
Yeah, it is there.
Awesome. Okay, so we just did this. I will. I'll just quickly. So, basically we saw something called Helm Center, right? Which is just a sheer example of how do you distribute Helm. You can also want to distribute to IoTs, right? So then you can push your binaries to edges. There is something called distribution which you can do. I'll keep moving fast. And then finally, you should be able to manage various kinds of binaries sitting in various instances, to kind of conclude a complex architecture, which I will not get into. But I wanted to spend some time on the runtime. When you move into production, especially in the context of DevOps, we had this whole concept of a machine, which is a bare metal machine, which was one and only one, and it had only one OS, and you can then deploy anything. And if you want to grow it, you need to now upgrade the machine to a larger one, which was the life that I saw in the 80s. In the 90s, we had virtual machines, which basically had a bare metal, and now you could put multiple similar looking virtual machines, and then you can expand. So you can have one big hardware and make it look like multiple. I'll come to exactly why I'm talking about this. Later came, recently, I think in the last decade, we had this whole concept of Docker, which basically pushed that up a layer, with operating system on the machine. And now Docker was leveraging and making it look like a different OS, right? This made it very, very useful, mainly because of the point that I mentioned in the beginning, where you wanted to incrementally update some piece of feature. And to update, you wanted to upgrade your system. And this made it very, very possible, because VMs used to take a lot of time to bring down and bring up. Docker was almost instantaneous when compared to that. And that really, really changed the way DevOps started working. And then came the problem of expanding these DevOps. Like, now I have one container in one box. Now, what if I want 20 containers in 20 different boxes? There were some concepts around, Compose, Docker Compose, Docker Swarm that came. But all in all, it was not as effective as what came later called Kubernetes, which is what is now really the hot area. And especially, someone asked, what are the skills I need to learn? If you want to really understand the runtime, you need to understand Kubernetes, which basically provides you a layer for you to control what you deploy, where you deploy, when you deploy, and that whole orchestration process. And that helps to exactly the point that I was mentioning, where you can say, hey, deploy only 2 of my 100 instances this feature. Let it get tested by various customers. If that is going right, automatically start moving that new feature across all my instances, right? You can play with those kind of things, and that is really made possible, with Kubernetes, and of course, some tooling around that, right? So that's really, I wanted to make sure you understand how this will all come together, to solve one problem of continuous deployment, which is where, Jfrog as a company and the ecosystem, we're kind of looking at liquefying software deployment, because, you should be able to reduce the small feature you build as small as possible and move that as fast as possible. Essentially, converting a big blocks of stones into liquid, right? So that's really what we are looking at. And just to pass around one small comment on 12-factor app. I don't know how many of you are aware of it. I suggest you to Google with lack of time. I want to make sure you understand how to build, a microservice, with whatever we spoke, with the DevOps centric, culture. Here are the things you should look at. Again, someone was asking, what are the skills I need to know? I think you should know these 12 points as and when you build, your code. You should know, there is one code for each service. I don't want to get into these. Please look for 12-factor app, and you will know, how large system should be created, so that you kind of give importance to all aspects of a software. It is not just about writing code. It is about testing. It is understanding dependencies, externalizing configuration, making sure you have a way to backing those services, etc., etc. I mean, point 11 is very important, which is kind of a very important aspect now that is picking up, which is the observability of software system and making sure what you build is observable, and therefore customers or whoever is using can understand what's going on within the application, right? So with that said, I just wanted to add one small point, and I'll pause there. Is when you look at startups, what typically they do is they give less importance to the process of DevOps, and they focus on the feature they develop, and they hit the scale, they pretty much as you see in red line, what happens is when they hit scale, their DevOps becomes slower than their growth, which breaks the company itself. Right? I think that is where I wanted to say DevOps is so important to start the green line. You start implementing it from day one so that you can scale as and when you build software. I think this is primarily important, because typically what I've seen is, hey, mine is a small piece of code. Why do I care about all of that? You have this principle in mind from day one so that when you scale, you don't have to come back. It is like a foundation of your house. Make sure your foundation is strong so that you can build layers and layers of building. So with that, I will park this. You please Google JFrog. But I wanted to just also talk about this. The presentation will be in jfrog.com show notes, including the video. And also we have a raffle. Please take a snapshot of this slide and answer a bunch of questions. And the top 10 winners will get a wonderful JFrog t-shirt. So with that, I stop. Happy to ask, if you have any more questions, happy to answer again.
Thank you, Prasanna. Thanks a lot. So with that, you given a bit of a giveaway as well for the students as well as young enthusiasts that, okay, they can answer the queries related to JFrog and basically DevOps, and then get a cool t-shirts, which basically the young developers aspire for. So thanks a lot for that. So we hope that we haven't got any more queries. So thanks a lot. Thanks, Prasanna, for joining in with us and helping us understand how actually DevOps is changing the way today industry is working. Thank you.
Thank you so much, Kaushik, and bye-bye.
Thanks a lot. So we had Prasanna Raghavendra with us. With this, we'll just get back quickly to the day 3 of GDTC where we were. So basically what we need to do today is that for those who have already done, it's pretty good. We would be deploying our projects using GitHub pages. So at the end of the day, we'll be having our own portfolios. So all those who are having any sort of queries or wanna get to know how to deploy it on GitHub pages, you can always ping us on Slack channel. So as well as we would be dropping in the link from where you can get the goodies for top 10 would be getting the goodies from JFrog. So that was it. Thanks a lot. Thank you everyone for joining in.